What up, y'all? Welcome back to some more C programming. Um, so I had the first couple videos I did that, you know, I was doing some exercises. You'll have to excuse me, I cut myself shaving. Um, I did the first couple videos doing the practical C programming, and while I do need to go back to that, I've just been the past week I've been playing Oblivion. Past week and a half been playing Oblivion Remastered. So I really just want to work on my project. I really just want to work on my image resizing tool and get this shit done, because I've kind of made it a goal for myself to finish what's on my plate before I start going and looking at other shit, basically. But because I'm bad about not finishing projects, you know, and I think that if I limit what's on my plate at once, then I'm less likely to, if I'm like, okay, I need to finish this project before I can start screwing her, because right now I really want to start messing with C++ and doing 3D games. Tokyo Spliff on YouTube, he's the GOAT. He like just smokes spliffs and sits on the couch, and he's building his own OpenGL C++ first person shooter. I do recall him recently saying that he hasn't been smoking spliffs, so you know, I'm not trying to paint him as just this stoner guy, but he does sit on the couch and he does toke darts and writes C++. But you know, that's really the goal. I mean, you know, who wants to do anything else? We're just gonna go over to my GitHub real quick. I'm gonna take a look at this Imagey repository. Let's just have a rundown of what I've done so far with the application. I want to say the last bit that I covered on the live stream I did, and I decided that I'm going to do these just longer form videos for now. The live stream just doesn't seem like it got much engagement, it just being a VOD, you know, and I don't have enough time in my day to like live stream for 4-hour blocks throughout the week. I mean, I could, but I wouldn't have a life. So I think that just doing these videos like this, that's basically a live stream format, only me yapping, you know, and it just feels more natural off bat, because if I do get you know, a few people that stay tuned into my channel, maybe I'll consider live streams more, because, you know, I don't know, I think it's almost a little bit more entertaining to know that I'm not talking to anyone than it is to just like yap endlessly to avoid I don't know what I'm saying. But anyway, we've got this block of code here, right? This function, our resize JPEG. This is what's actually going to be looking at our pixel data and doing some shit to actually resize it. So headphones are kind of on cockeyed. Let me check. Is my mic working okay? Hello. Yeah, it is. Okay. Cool. Yeah. So we're dealing with a raw pixel data buffer, right? So the way my image resizing program works is image resizing algorithms. Yeah, there's a bunch of different ones, and basically what I'm trying to do is what's called nearest neighbor, and you'll see nearest neighbor interpolation, and a lot of different things, not just image resizing. I think like pixel applications are the most common for it. I was watching the Tim Sweeney, Lex Friedman. He may have been talking about context of John Carmack, but he talks about some nearest neighbor use that they had. But yeah, there's a lot of different algorithms you can apply to resize the image better, or differently, I guess you could say. Nearest neighbor is it's simplest to integrate, even though it's still hard for my pea brain. Simplest to implement, but it also isn't really the best for, like, you know, picture quality wise. It kind of gets a little pixelated, which the scary part of writing this program has been is that I don't know what the hell the resized pixels is going to look like. Like, is it even going to resemble the original image? I mean, I'm playing with the raw RGB values. I'm hoping to God that it even somewhat resembles the source image once it actually all compiles. But that's foreshadowing. It doesn't work yet. It still doesn't work. This is really just going to be me working on it and trying to figure out what the hell to do next in this video, because yeah, there's no real use to this content other than sort of brain rot, I guess, just to watch me rot my brain. But yeah, we have this resized JPEG algorithm. Our main beef here, our main course is this double for loop. That the double for loop is doing two things. So down in our do read JPEG, we have one for loop that all it does is populate our buffer. Well, sorry, scratch that. This populates our row pointers, which are pointers to each row of our buffer. And then we have our while loop that actually populates the buffer. This reads scan lines. It, you know, writes to these row pointers, which is where our buffer actually lives. Okay. Yeah, and then we have some debug, you know, printing some pixels. So in our 3360 by, what is the, I have it written down here, 2100 image, pixel 3360 will be the last in our first row, because, you know, you're looking at an image. I'll use my magic trackpad for example. You know, this is 00, right? And then 3360, that's how wide it is. You know, it's like 1920 by 1080 or 2160 by 1440 or 3060 by 2100 in my case. So, you know, that's just the width of the image. So 3060, pixel 3060 is going to be on this edge, the last pixel of the top column. Now there's going to be 2100 rows all up and down it, and 3360 columns across it, right? So yeah, that is representing the last pixel of our last row. If we wanted to see the last pixel of our second row, then we would just have to, it would be pixel 3360 on row 2. Or there's a lot going on here. Shit. Yeah. Okay. Because, yeah, okay, now, sorry. This position of 10,078, and then you have like this here, this is representing 1 pixel, right? So in position, since we can represent the 1 pixel's pixel values with 3 RGB values, trying to think of a good way to put that. What the fuck? Yeah, we're representing a pixel with 3 values. So 3,360 times 3. If there's 303,060 pixels in one row, then there will be 10,080 actual values to make up those 3,360 pixels. Yeah. So in our buffer, if we wanted to see what the last pixel of the second row would be, we'd have to go another row's length in the index. So 10,078 or 10,080 times 2 will be where the last pixel, or the B value in our last pixel would be, and then you go up from there, you know. So then 20,160, it would be 20,160, 58, 59, then 60, yeah. So we can actually just do that real quick. Pixel 3060, second row. Then we'll do 20,158, 2159. Oh shit, I accidentally copied 2160. And then we'll oh yeah. Cool. Okay, so thankfully we can see that it is different. Sorry, my brain's moving a little slow today. I've been fighting a bug the last 2 days at work in Java that was just a stupid Maven package error, and as it always is in Java. Yes, I use Maven. I'm a Java noob, so if Gradle is the GOAT, then let me know. Yeah, so thankfully it's slightly different, so we know that the values, it is giving us what we expect. We'll go ahead and just delete that. That was just for demonstration. So we have this resize JPEG function here that then will take in the full buffer from this, right? So we write to the full buffer, we do a little, hey, this is some pixel data just to prove it's a real full buffer and not a fake full buffer, and then we call then resize JPEG that is going to be reading from this full buffer and creating a new buffer to house our resized image, and it also takes, you know, the out file path to determine where to write this new file. And I'm passing around this out file path between all my functions. It'll be okay. Yeah. So from the top on resize JPEG, we initialize some stuff. We initialize a couple integers in order to store a pixel value or a pixel position from our source, which is our input buffer in this context. And then we initialize an offset and a resize offset. So those are going to be a calculation to, we're going to calculate an offset for each in order to know which pixel in which position should go from the input buffer to the resize buffer. So we'll look more at that down below. I just hard coded output width and height. Once the application, works a little bit better, we can, maybe do something like this, but then provide, -O, or maybe we do that before, something like bin image. Sorry, I'm fumbling the bag right now. And we do like 800 by 600, and then test images move. Just for example, I'm sitting here convincing myself that it's already working. Yeah. So then we initialize the pointer to a sequence of bytes, I think is the proper term for this. Or maybe okay. This just initializes it. Row stride, yeah. That's the same calculation we were doing in our do read, which is just getting the total length and position, like how many elements are going to make up the array that is a row, which would be 800 by times 3, how we talked about. There's 3 different RGB values, will represent a pixel with 3 numbers. Yeah. So blah 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 blah. I initialize a couple dist variables because we're doing this in C99, and you can't do an inline int I like that. Does not like that. It also does not like this. A comment. Yeah, I believe you can do that in C11 and above, or maybe there's like an early 2000s one. Whatever. Now we're looking at our actual for loop here, and this is initializing our row pointers like we did below, calculating our source Y pixel to pull from, and then we do not need to calculate this each time. Source X is row independent. Okay. Yeah, so this should probably be... Yeah, since source X is row independent, yeah. Sorry, it's been a couple weeks, like I said, since I've really dove into this code and just kind of talked out loud about it. Yeah. So we could pre-calculate this instead of doing this in for every pixel. And the song bangs. Calculating the offset to pull from our input buffer and the resize offset in order to put. This is the positional value of where we're placing the pixel from our input buffer, which this is the positional value of the input buffer, which we're pulling from. Okay, yeah, and then we're just doing some debugging here, which is you're seeing whenever I run the program, like, yeah, when I run the program, that's what you're seeing here. These new line prints. Yeah, and excuse Lisp. I got Invisalign in, so we're struggling through it. All right. So you're all caught up. You know how it works. Very simple. now it is going to be time to okay. Now we have our save JPEG. I wrote this last night, I want to say. Yeah, basically what I found out is that we need a compression struct just the same way we need a decompression struct in our first part of our program. In our do read JPEG, which is also in resize JPEG, but we're just using it to read some metadata values from it. Okay. Save JPEG. We're creating this compression struct, setting up our error manager, initializing the compression struct. And then we are actually utilizing this write file function from helper C, which is on some dry rule shit right now. Like, the only thing different between these two functions is this, but one is read binary, one is write binary. But hey, in my actual code where I'm using it, it's clear that way. I'm totally forgetting how to use Vim. Yeah, so we have this JPEG standard IO destination, write file, out file path. Did I get it to work last night? Like, what's going on here? You know? Don't look at my files, y'all. Oop. Test images. 0 bytes. So, okay. So yeah, we need to oh, we're in knee deep with shit. All right, we're running 24 minutes. Good. Good. We can actually maybe start diving into this a little bit. So we're doing this standard Input output destination. Yeah. This is in. Yeah. Cool. Okay, next thing we want to do, we want to tell our compression struct about our image, which already exposes a flaw. I gotta move my camera up, sorry. With our save JPEG, we're gonna have to take that integer so why in the fuck did I? Oh, we made them floats because we have to do division with them. But that doesn't even make any fucking sense. Fuck it. We're just gonna make them floats for now. Oh. Loud. Resize. Wait, what are they fucking called? Output. Width and height. Width and height. Alright. Yeah. Alright, yeah, we gotta. This is probably gonna. Let's see if this even compiles, actually. What am I doing? I'm stupid as hell. Format specifies type double. Unsigned int. Okay. Maybe it does some implicit conversion or some shit. Damn, this like was blending in crazy with the background. Okay. 600. Okay, it does do some implicit conversion shit. Cool. Image width. And then we'll go ahead and just double check to confirm we're fucking. Just because I think all these print statements are so ugly, but they're sort of necessary right now. So we're getting resize width. Oh, okay. I wish I was fucking better at Vim. Okay. That's the key. Wow. The song doing that whenever I realized that's all I really need to worry about is just like movie shit. This song is good, but I don't feel like listening to it. Nor that. Okay. So start compression is where I'm gonna take this JPEG start compress. We'll go ahead. What's going on? Okay. It's that stupid highlight. JPEG start compress. Comp. Yeah, okay. Just for example, sorry, I'm just really trying to absorb this. The start decomp. Yeah, this honestly is less daunting than what we're reading now. But for example, in this do read JPEG, this is where it's providing an example for reading a JPEG, obviously. We do this create decompress struct, blah, 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 blah. Yeah. It was this shit here that there's lots of different if statements to be able to handle every possible different as JPEG image. But once I found out that I'm like, oh, this while loop here is really the default case and all we're really concerned with for our program. So read scan lines is it's reading from a buffer into a struct. I mean, that's the same thing we're doing up above. So let's go here again and take a look. Okay. This is essentially what we're doing. So maybe we should stop here and take a look at our Obsidian notes and just kind of update ourselves on what's going on with this. I include all this in my README and my repo just as a good note-taking thing, but sometimes I realize I fuck up the formatting because of Markdown being Markdown, and I make the changes here instead of in Obsidian. So yeah, sometimes I have to deal with shit like copy and pasting over between them. Okay. We've last told the user that we are writing to this resize buffer, or we've last told the interested soul that values my wall of text. Yeah. So we wrote that shit into the resize buffer. Hell yeah! Now what's next? We're calling the dog shit out that save JPEG function, and that's really where our program is getting like pixel backshots. So yeah, we get this little thing here, and we're gonna go ahead and my bad, y'all. Let's take a look at so we've already resized JPEG. That's not proof that I haven't updated the top part of this in a while. And also, I'm thinking that we actually aren't going to want to pass the whole buffer here, and just our array of row pointers, which point to the rows in our buffer, so there's no reason to pull or point to the buffer. But maybe I'm wrong. No, we'll need both because in order to write the pixels into the compression struct, we're gonna have to use the row pointers. Maybe that's all we need. I don't know. We'll get there. Resize buffer. I'm just documenting this function. Char star out file path. Oh shit. Float. Just copy that in. shit. Sorry. Trying to remember if I can even copy and paste between shit. Hell no. I don't have that working right. Float. Oh no. Resize width. Well, I'm not going to take up too much more of your time, so I probably should just go ahead and plug my fucking phone in. That would make sense, wouldn't it? Alright. Yeah, so we're documenting that function there. This is, yeah, documenting progress. Now is time to give our new resize buffer over to our resize or save JPEG. But only in raw pixel data form. We are going to pass this data into our save JPEG. That's a function, not a buffer. Save JPEG function that will handle writing the data into a JPEG compress struct, much like we pass the source image into a could have just fucking typed that out at that point, Jesus. Yeah. Much like we pass the source image into, we are initializing this struct, creating a new error managing struct for compression, and loading it up with the header data like resize. Okay, yeah, that's what we're doing. We're loading it up with some of that. Then we're doing some set default shit. Yeah. Of then which we have this. Yeah, it seems like after we do this start compress thing, we're kind of ready to start writing scan lines. So I'm just gonna copy this shit in here like this. Oh shit. Yeah, we're gonna put these in comment jail for now. What the fuck? Within block comment. I'm fucking confused. God damn it. Oh my god, are you serious? Okay. So row pointer 0. Alright, y'all. I'm actually thinking I'm going to call it here. I'm not necessarily burnt out, but we're coming up on an hour. And yeah, I don't know. I just wanted to get on here and yap and try to make some progress and show off my image resizing tool. Excuse me, by the way. So yeah, I guess I haven't really stated that, but this is a image resizing tool in C that is messing with raw pixel data, which is JPEG.h. Sorry. Yeah, so we hadn't made much progress today, but yeah, we're just chilling. We made more progress than maybe we would have thought, you know. But now we have a plan of attack. I want to spend more time with this off video, and the next video maybe we'll actually see some resized image. So that's cool. Hell yeah. All right. Appreciate y'all for watching. We'll make more videos and shit. For sure. See y'all.